Hey everyone, and welcome to another Explainer. Today, we're diving into something that is just absolutely mind-blowing. Now, I know we often think of math as just, tedious numbers on a chalkboard, right? Like something you slog through in school and immediately try to forget. But what if I told you math isn't just numbers? It's actually the source code of our entire universe. Today, we're going to uncover the unseen architecture of reality itself.
Because, look, history usually teaches us that the world gets changed by, say, mighty armies, massive empires, or these sweeping political revolutions. But there's this quiet, immense power that almost always gets completely overlooked. Think about it. A handful of humans, scattered across centuries, managed to change absolutely everything simply by scratching a few symbols onto a piece of paper. And those symbols, they didn't just describe reality, they actively reshaped it.
Okay, let's dive into this. Here is our roadmap for today. First, decoding reality's source code. Then, mastering space and gravity. Next up, light, waves, and time. After that, mass and the quantum realm. Then we'll hit the laws of information. And finally, the power of ideas. Let's get to it.
Section 1. Decoding reality's source code. The first rules.
So the cool thing here is you absolutely do not need to be a mathematician to appreciate these world-changing moments. The true magic isn't in the complex arithmetic itself. It's in that profound moment someone finally wrote these rules down and the world was just never the same. We're charting a massive evolutionary leap here. We're starting way back in 500 BC with Pythagoras mapping ancient geometry, and we're traveling all the way up to 1948 with Claude Shannon, who literally mapped out the digital code running inside the very device you're using to watch this right now. Section 2. Mastering space and gravity, unifying the heavens and earth. This marks the specific era where humanity first learned how to perfectly measure distance and began predicting the incredible physical forces pulling at everything around us. And we have to begin with one of the oldest equations in recorded history, Pythagoras' theorem. A squared plus b squared equals c squared. Now, the crucial point here isn't the high school math test you might be having nightmares about. No, it's that this universal rule unlocked our ability to measure distances perfectly without actually having to physically cross them. Because of this exact equation, we got surveying, secure architecture, perfectly straight pyramids, and yes, the modern GPS system you use every single day. It was our first real taste of the idea that the universe actually follows perfect, unchanging rules. Then, we fast forward to 1687, and we get Isaac Newton's law of universal gravitation. This is the formula proving that the force between any two objects is based directly on their mass and how far apart they are. Honestly, it is just awe-inspiring to realize that Newton essentially unified the heavens and the earth under one single law for the very first time in human history. Just look at the earthly forces here, like your coffee mug falling off your desk or an apple dropping from a tree. Now compare that to the heavenly forces, the moon orbiting the earth, entire galaxies moving through the void, spacecraft navigating the stars. The exact same equation keeping your coffee mug sitting on your table is the exact same one that allows us to perfectly program a spacecraft to reach the outer edges of the solar system and arrive exactly on schedule decades later. How wild is that?
Section 3. Light, waves, and time. Unlocking the invisible.
Let's move to the 1800s and see how humanity actually mastered the untouchable, invisible forces that dictate energy. Enter James Clerk Maxwell in the 1860s. So he took everything humanity knew about electricity and magnetism and he compressed it all into 4 incredibly elegant equations. But here is the absolute best part. In doing that, he showed that these fields could propagate through space as a wave. He calculated the speed of that wave, and wouldn't you know it, it matched the speed of light perfectly. He accidentally proved that light itself is an electromagnetic wave. And it didn't just describe visible light either. His math brilliantly predicted the entire unseen electromagnetic spectrum hiding throughout the universe. Now, what's really interesting about this next bit is a quote from Heinrich Hertz. He's the scientist who experimentally proved Maxwell's theory by actually discovering radio waves. So someone asks him what his amazing, groundbreaking discovery was actually good for in practical terms. His answer? Nothing, I guess. I mean, wow, he was magnificently, wonderfully wrong about his own monumental discovery. Because just look at Maxwell's modern legacy today. Wi-Fi, Bluetooth, headphones, smartphones, microwaves, X-rays, the whole shebang. I want you to really think about this right now. Every single piece of wireless tech you own, literally, the very connection bringing this explainer to your screen, it only exists because Maxwell sat down and unified those invisible forces into 4 lines of math on a piece of paper. It's a real game changer. But, the universe isn't just about forces. It's also about direction.
Think about a perfectly intact ice cube melting into a puddle of water. This perfectly illustrates the second law of thermodynamics, or entropy. It mathematically proves why disorder always increases. Heat flows from hot to cold, never the reverse. You can't unmelt the ice cube, right? It's the ultimate rule that gives us the arrow of time. It explains why time only flows in one direction, strictly separating yesterday from tomorrow.
Section 4. Mass and the Quantum Realm, Ultimate Power and Probability.
Okay, we are now transitioning into the 1900s. And fair warning, this is the era where the fundamental rules of the universe start getting incredibly weird, but unbelievably powerful. Naturally, no list like this would be complete without Einstein's mass-energy equivalence, E equals mc squared. This is the seemingly insane but absolutely true concept that mass and energy are fundamentally the exact same thing. What really blows my mind here is that Einstein wrote this world-changing formula purely as a theoretical footnote. He wasn't trying to build a reactor. He was just following the logic of special relativity, using nothing but a pencil and his own sheer thought.
Let's put the scale of that equation into perspective for a second. 90 quadrillion joules. That is the amount of energy locked inside just one single kilogram of matter. Why? Because you're multiplying mass by the speed of light squared. If it were perfectly converted, that 1 kilogram could power the entirety of New York City for 2 whole years. 2 years. This simple equation explains the relentless burning of the sun and the raw, terrifying power of nuclear energy.
But while Einstein was busy mastering the massive energies of stars, the microscopic world was playing by entirely different rules. In 1926, Schrödinger's equation emerged. It's a formula describing how quantum systems evolve over time. But here's the catch. Instead of tracking a particle's exact location, it tracks the probability of where it might be. And honestly, this disturbed Einstein deeply. He famously refused to believe that God plays dice with the universe. But experiment after experiment has proven that Schrödinger's superposition completely rules the microscopic world.
So why should you care about all this abstract quantum weirdness? Well, because it is the literal foundation of our modern world. The entire semiconductor industry, transistors, computer chips, laptops, the internet itself. Every single transistor operates according to quantum tunneling, a phenomenon this exact equation predicts. Without Schrödinger's equation, you flat out wouldn't have the device you are currently looking at to view this explainer. The weirdness of quantum mechanics is literally running your life. Section 5. The Laws of Information, Encoding the Digital Era. And that brings us to our final evolutionary leap. We are stepping away from physical atoms and moving into the realm of pure data. Enter Shannon's information entropy in 1948. This equation defines the fundamental mathematical limit of how much information can be compressed and transmitted without loss. This, right here, is the foundation of our entire digital communication system. We're talking file compression, JPEG images, MP3 audio, streaming video, mobile networks, even the very invention of the bit itself. It all traces back to the limits Claude Shannon described. But get this, the genius behind it wasn't your typical stuffy academic. Claude Shannon quietly wrote the mathematical foundation of the internet while famously riding unicycles through the halls of Bell Labs and building custom juggling machines. I mean, he was an incredibly eccentric, brilliant mind who essentially handed us the modern digital age in between his juggling sessions. If Einstein gave us the laws of energy, Shannon absolutely gave us the laws of information itself.
Section 6. The Power of Ideas, from Scratches to Systems.
As we wrap things up, let's just take a second to reflect on the massive journey we've taken across thousands of years today. It all started with just a few scratches on a piece of paper. But those scratches, they eventually lit up our modern cities, they connected billions of people globally, and they sent complex machines out to the very edges of the solar system. It is absolutely marvelous to think that individuals, sitting totally alone with a problem and just following logic wherever it led them, managed to decipher the universal language of mathematics and completely change reality itself.
Which leaves us with a final massive thought. The universe clearly has rules. Bit by bit, equation by equation, we're learning to read them. But which ones haven't we discovered yet? Thank you so much for joining me on this explainer. Keep questioning the unseen architecture all around you. If you found this as fascinating as I do, please subscribe to keep learning with us, and definitely go explore the criminally underrated genius of Claude Shannon. See you next time.